Hello everyone. Can you see me and hear me? Someone, anyone can assure me?
Oh, yes, ma'am.
Yeah. So how are you all? Why so silent? This is a discussion course, so you should all be a bit open for discussions. We will start in a while. Some people are still joining, so we'll wait for a few minutes and then we'll discuss certain questions from previous year, which might help you in solving your current assignments. I guess you all have your week one assignments with you guys, right? Right now, we are very less in number, hoping number will increase in a few minutes. So in a meanwhile, all of you can text in the chat box, like which program you all belong to. Is it the UG program or a PG program or something else? So that we can have an idea about the spread of our audience, and it will help me to schedule the upcoming lectures in that manner. Can we do this?
Yes, ma'am.
Yeah, so please go ahead. And it's okay if you're not comfortable in unmuting and saying something or telling something. Every one of you can text in the chat box. I will go through it. Even if you have certain questions, we can take those questions in the end. Also, I will encourage every one of you to join the discussion forum of the NPTEL course. I will also be answering certain questions there. Till now, I haven't received any uh,
So, ma'am,
chat message. हाँ, बोलिए.
yeah, myself, Dr. Pradeep Kagane.
Yes, sir.
Basically, I'm a vet professional.
Okay.
Now I'm 58.
Okay.
Now I have joined this course.
Okay. Like what were you? Second, I want to know everyone is comfortable in English, right? I can speak in Hindi also. No problem.
Yeah.
Huh.
Get
Okay. Go
comfortable.
ahead. Okay. So you were telling?
So I was telling that I'm doing this course
Hmm.
just to convert waste, particularly bio waste,
Hmm.
to energy.
Hmm.
Because I'm
Hmm.
working with farmers currently,
Okay. Hmm.
that too with livestock farmers.
Okay. Hmm. Hmm.
So I'm having two kind of biomass.
Hmm.
One is a large quantity of govardhan,
Yeah.
which is a livestock
Hmm. Hmm. Hmm.
waste,
Hmm. Hmm.
and this paddy waste or other kind of biomass. So planning to do some big project.
Okay.
This is what is my objective behind this joining the course.
Okay. Which area you are in, sir?
I'm working with Animal Husbandry Department, Government of Maharashtra.
Oh, okay. Okay.
Yeah,
Very
and
nice.
just after 4 months, I'm retiring from my service.
Oh, okay.
So full time I can
Nice.
work for this project.
Very nice. Very noble initiative. It is one of, what should I say? The managing livestock and managing waste generated from the livestock is one of the challenge, because a lot of thing can be done with the waste product, which we say it's a waste because we don't know how to process it with respect to the things which will be helpful for us. Like you must be knowing about biofuel and all, right? Biofuel, biogas,
Well,
primarily in the rural areas. Huh.
see, actually, what happens? We
Hmm.
livestock industry people, we are carrying a stigma that we are the biggest methane emitters,
Okay.
isn't it? So what I
Hmm.
feel that definitely there are technologies by which we can convert methane
Hmm.
into a good amount of energy.
Yeah.
After completing this course, definitely I will be in a position that at least some technology will be in my hand, uh, so that we can make a big change in this
Hmm.
field, in this
Hmm.
livestock industry.
See, mostly what I can guarantee you is that this course will help you in knowing what things are already available, right? Because
Yeah,
आप लोग ने अभी तक, like you have gone through the first week का course, so mostly it's a theoretical course. Some things are there for numerical perspective, but those are not to be scared of or thought of like, oh, it's a numerical course. No, it's mostly it's a theoretical course. It will guide you, it will tell you what are the things already present and what are the principles behind it. Because, for example, if we have, I guess we will go back to the introductory class. I will skip through the slides, which you might have gone through while attending the course.
yeah,
That all things are CHNOS, right? Everything at the end of the day, we are using these things. There are n number of ways we can utilize this for energy production or for mass production or for just say anything, XYZ thing. At the end of the day, it is all about these elements, CHONS,
right.
right? So you talking about methane, again, carbohydrate, CH, right?
Of course.
So utilizing carbohydrate, because we are organic beings, right? Both livestock as well as, yes, Rudra, I will take your question in a while. So CH, these are all carbohydrates. We are organic beings because we use carbohydrates for n number of things. So the thing which is giving us energy, it's the ATP, right? We get ATP by using electrons. Electrons released from a carbohydrate source, glucose. Similarly for plants and all the living beings. At the end of the day, if you have a commodity that is methane, there are ways through which you can use this raw material for producing energy, and that energy can be utilized for n number of ways, like in whatever you are targeting it. And I will like to involve other people in the discussion also. I guess Rudra, you had your hands up. You raised your
Ma'am, am
hand.
I audible?
Yes, yes, you are audible.
Ma'am, I have a question. Ma'am, first
Hmm.
of all, I am a BTech student.
Okay.
So, ma'am, the main concern of our environment is the plastic deposits and all the non-biodegradable polymers which are getting deposits in sea and landfill area. And
Correct.
the main issue with dealing and managing them is we can't segregate on the basis of the components or the compounds that it had. It may be polyester, it may be polyethylene,
Yeah, yeah,
or so, ma'am, can we make a single reactor in
yeah.
which we can put all the plastics, whether it's thermostat, thermosetting,
Hmm.
nylon, polyesters, or any such any non-biodegradable plastic, and can we convert them into energy by that reactor or by that any process means? And even if we want to recycle those used plastic, is it possible that we can make a homogeneous mixture and from all the waste of plastics we can generate some products from that?
Hmm. See, it's a good thought, but coming back to the technical details or the, what to say, uh, the technology which is currently up, because we have n number of ideas, right? But we need to limit ourselves based on the technological advancement currently we have in our hands, right? So let's take a very layman example. Like, I'm just speaking as I'm thinking. For example, you are mixing two types of plastics here, right? A and B type of plastic. They both have different chemistry in them. For example, for one plastic, the melting temperature may be X. For B plastic, the melting temperature can be X minus 1 or X plus 1 or X plus some other number. So we cannot homogenize multiple things in one go, because you are producing energy, right? But to produce energy, you need to provide energy also. So it's a very like a trade-off thing. So if you are doing something, you need to calculate whether the energy produced is more than the process or the energy required to do the process. There is a reason we separate solid waste and solid waste, liquid waste, and gaseous waste. See, in municipal waste, we have all these things, right? But we separate solids from it and then liquid waste from it. Why? Because both of these components have different characteristics. So if you're trying to impart same process or same unit operation to two different types of uh, material which has different characteristics, the chances are you will be imparting more energy to it rather than generating more energy from it. It's a very basic thing, right? The thought which you said, it's like, again, even for the universe, we are looking for unified equation, right? Which can explain everything. But there are n number of complexities while dealing with heterogeneous mixtures. Homogeneous mixtures are pretty easy because you have uniformity throughout. For heterogeneous mixtures, there are complexities which further enhance the input of energy or the unit operations, these things. So in a way, from an industrial point of view, they are not at all energy efficient, because in industry, we always talk about energy as a currency. So if we are imparting more energy or more currency to a system instead of the value which we are getting from it, it is not a feasible work. Correct? I might be clear.
Yes, ma'am.
Yeah. So I think we have enough participant, and it's almost 10 minutes above our scheduled class. So just quickly, everyone text me in the chat box, like to which background you all belong to, either a UG or a PG student or a professional, as Pradeep sir said. Second, I will request you all to please mute your mics so that there is no disturbance for others. Second, I will, after the end of every question which I'll be discussing, I will ask you if you have any doubts. You can ask doubts then, as well as you can ask doubts in the end. In between, you can interrupt me, but it will be helpful for others, because when we interrupt in between, chances are their understanding and their flow might get disrupted. So this is just a few nooks and groups, and it's a pretty open platform. We can discuss, we can talk, and it's a waste to energy conversion. So basically, first we will go through the introduction slide, which I hope every one of you have followed Professor Mandal in the first week of course layout, and then we will discuss some of the previous year questions and how to solve them. Chances are this might help you in solving your current assignment, and I think your deadline might be next week for assignment submission. Correct? So, okay, BTech in biotechnology, UG students, electrical engineering, very nice. Oh, yes, sir. Then, okay, very nice. We have very diversified group here, so it will be a good discussion to everyone. So I will be sharing now the first introduction slide, which you guys might have seen already. Okay. Can you see my slides?
Yes, ma'am.
Hello. Yeah. So, ये first introduction slide है. Every one of you might have gone through it. So, can anyone brief me what was the motive of this first slide? It's a open thing. Everything is written on the slide. What was the objective of this slide? This will help you in solving the questions. This is kind of a revision to all of you.
So, ma'am, what I
Huh.
feel that the major objective behind presenting this slide is how much is the big potential in India for the waste generation, and so
Yeah.
converting waste to the energy or to other valuable products. There's a huge. We can set up a huge enterprise. It's a big
Yeah.
entrepreneurship opportunities in this domain, particularly.
And as
that is
we were
what is
discussing, yes, sir.
yeah
And
that is what
as we were
my
discussing earlier also, that before going for anything, for processing anything or generating energy from a thing, we should know what kind of a thing it is, right? Is it a liquid? Is it a solid? Is it a gas? And if it is a gas, what are the major components in it? Or if it is a solid, what are the major components in it? Same with the liquid. Correct. Then, okay, I want to pose this question. You guys have went through the first week's lecture. Why do we need waste to energy conversion? And I like other people to please respond who has not yet responded. I can see many people in the participants. So don't shy. Like everyone is new here, everyone is learning. So go ahead, whatever you think. Why we need to learn waste to energy conversion, or why you have selected this course for, like, there must be a particular objective behind opting this course on NPTEL, right? So what were your uh, motivation behind selecting this course, or what you think exactly waste to energy conversion is? Anyone. It's a pretty non-formal meet. I'm also a student. I'm just a PhD student like you all. Just share in whatever language you are comfortable with.
मैम मुझे ये लग रहा है कि इसी एक काम से तीन अपने ऑब्जेक्टिव पूरे होने वाले हैं। पहला तो पब्लिक हेल्थ कंसर्न जो है वो अपन रिड्यूस कर सकते हैं। सेकंड, एनवायरमेंट प्रोटेक्शन या क्लीन एनवायरमेंट का ऑब्जेक्टिव पूरा हो सकता है।
करेक्ट।
एंड द थर्ड वन इज एनर्जी सिक्योरिटी, दिस इज वेरी इंपॉर्टेंट।
व्हाई वी नीड एनर्जी सिक्योरिटी? मतलब वी हैव एनर्जी, राइट? मतलब अभी भी आपके घर पे भी लाइट जल रहा है, मेरे घर पे भी लाइट जल रहा है. So why we need more energy when we already have enough energy with us? Generic question to everyone.
Yeah, the energy which we have, it has a good amount of carbon footprint. So we need the clean energy. And definitely, to certain extent, by using this waste to energy conversion, as compared to this traditional energy or the power generation plant, to certain extent, we can save the carbon footprint. This is what is my belief.
Okay. See, so you are not wrong, but we are again here, we are conducting this lecture so that we can get more clear in our concepts. You are using term like clean energy, right? And you use the term carbon footprint. So why carbon footprint is a bad thing, or why clean energy is a good thing? And 1 minute, sir. Others, please be in the discussion. It is a learning thing. Everyone can put their opinions. We will go to the questions which will help you in your assignment, but discussions like this will help you in understanding and getting maximum out of this course. Okay. If you all are comfortable, I can keep my video on. And if you are okay, I can keep my video off. It's up to you. Just text me in the chat box and also be very active in the discussion. Pradeep, so I will come back to you, but I want others also to participate in the discussion.
Sure, ma'am.
Yes, sir. So anyone, Adarsh, Ayush, I can see these names. Ekta, Harsha. It's a very, you have gone through the first week, right? So I think you all might have a certain or little bit of idea why we need waste to energy conversion, or at least just tell me why you opted this course. You can
Madam,
unmute yourself. Go ahead.
Madam, actually increasing the population, the need of disposing the waste also a major important thing. So we are it's already waste, so we don't have any profit from that. As a business point of view, also it will be helpful. Like we are generating energy from the waste, and also environment part also it will be protected from that. So this course this course means we will get some idea regarding what is the existing trend, also what we can implement here, what it was not here. So it will somehow advance our in this concept.
So can I say this in a very, like, whatever you have told me, it's correct, but can I put this in simple terms and say we have a lot of waste for which we don't have any place, right? Because earlier what used to happen, if you remember, like even today, this is the trend that landfills are there, right? We have very big burrows in the earth in which we just dump our waste material. But is it the feasible way to tackle waste of millions of people on daily basis? Again, not even considering the waste from industries which are like large scale industry, right? I'm just talking about the household waste. So everyone who is alive is generating waste in one way or the other. One is the organic waste, which we excrete from our body, which is the municipal waste. The other is the waste from the products which we use, right? If we are having some processed food, if we are buying something, we take that bag or polythene, right? And we discard them right away. We use canned drink products. Wherever we go, we are generating waste, correct? So if we do not have a proper uh, protocol in place to handle this, it is already a problem. Like when I was studying, when I was in my school, even then it was said, okay, waste management is a problem. So 10 years down the line, still that problem is very real, but no such thing or a major thing has been done to curb it. So here comes the role of scientists and the science and the technology, where what we said is that, okay, we have some raw material, right? It can be of any type. It can be a fruit peel, it can be a plastic, it can be a thermocol, it can be a cardboard. Okay, so we have some raw material. Every raw material has some form of energy in it, right? Because some amount of energy was delivered on that product during manufacture. Because when we compress things, when we expand things, energy is being given to it. And as the natural and the universal law, energy can neither be created nor be destroyed. So if we have given energy to something, can we extract the same amount of energy or at least some amount of energy from the product? Here comes the role of this subject, which basically it does is that it breaks the commodity into its constituent elements, because energy is always in the form of constituent elements. Even for us, we living beings, we use ATP, which is adenosine triphosphate. Phosphate is the commodity which is giving us energy, right? So it's a molecule. So if we are able to break commodity in such a manner that it can be converted into its constituent element and releasing energy, then we can to some extent curb the problem of waste handling, landfills, or just say make a better life for ourselves. The energy production from it is a secondary thing. Our first aim was to tackle the waste. How we are tackling the waste? We are getting the energy from that waste. Okay. Now we'll see. Okay, can anyone summarize this slide? What Professor Mandal told in this slide, or what was the objective of this slide? Hello.
Yes, madam. For handling, for creating the energy from the waste, based on the nature of the waste, some properties we are to looking from that. For example,
So
for
these,
solid, for
correct,
solid
correct,
waste,
go ahead.
for solid waste, for combustion characteristics, carbon and hydrogen required. What is the content in that, and the heating value also, how much energy has got liberated during combustion or gasification or processing time. And wastewater also, BOD, COD, total organic content. These three will be after the extraction, after the separation, whatever the dissolved components it was there, it have some energy while burning or processing them. And waste gas also same thing. While processing time, how much energy will can. And these properties, from these properties, we have the idea this waste having this much, we can get some energy from that. So,
correct.
That only.
Again, it's a very theoretical subject. You can look at the basic backbone of things. For example, in solid waste, what we can use to get energy, right? We can use elemental composition, because these elemental composition will give us the energy which we need. For wastewater, what we can have BOD, COD, and TOC, because these will tell us whether the water is okay for being consumed for n number of purposes. There can be water for washing purpose or for drinking purpose, or can it be treated further for laboratory purposes or not. For gases, again, because gas or waste gas is one of the major cause of greenhouse. I guess everyone agree with me on this, right?
Yes, ma'am.
Everyone can give a thumbs up in the chat if people are not comfortable with unmuting themselves, so that I can know my point is being conveyed and I don't need to put much pressure on it. Then moving to the next slide, what we study, or what was the motive of this slide? Anyone?
What are the properties earlier highlighted? That only, ma'am, here summarized.
Sorry?
The earlier, whatever highlighted properties, that only here highlighted.
At the end of the day, it is with respect to the what kind of product is helpful or is required for energy production. It is a similar thing. Moving to the next slide, it is for the how solid waste are classified. So can anyone tell me in their language what it, apart from what is written here, what is a solid waste? Pretty easy, simple words. I want you to tell me simple words, because when you tell things in simple words, it gets imbibed in your brain and you understand the concept of it, rather than just mugging up the lines which are written, right? It's a very simple.
Ma'am, solid waste is basically useless and sometimes hazardous material without low liquid content,
With low.
which
Good.
it includes municipal garbage and all.
Perfect, perfect. We'll move to second one. What was the, it is again, it was just the classification of solid waste based on source from which we are getting the raw material. Here I'm using raw material, not because it is actually raw in nature. It's because in any industrial process, whatever the input is there, we call them in very general term as raw material. So we can classify solid waste on the basis of source, on the basis of biodegradability, on the basis of combustibility, compostability, and at the end of the day, usability. Correct? Any other ways if any other way anyone want to suggest that we can classify solid waste? If anyone has any as a think करके idea, oh, this category can also be included in this classification. Source हो गया, from where we are getting, biodegradability हो गई, whether we can biodegrade it or not, combustibility हो गई, whether it is fumable or not fumable, compostability हो गई, whether it can be degraded enough by microbes, or usability हो गई, can we reuse it, or is it an organic type of thing, or it is completely inert and we cannot do anything. According to me, I cannot think of any other way a solid waste can be classified. If you have anything, let me know in the chat box. Then coming to the next slide, again, it was just a slide for you to have an idea what exactly comprises of these solid waste and what are their composition in with respect to India. Because if you know the data, then only you can imply some of the principles or techniques for targeting. For example, if you have a very important technique and you have generated a good pipeline, but that targets only this 8% section of the 8% section. So going for a funding, it might not sit well for you, right? Because at the end of the day, we need to look for money also. For doing anything, you need money. So if you know that, okay, 50% comprises of biodegradable waste. From this data, we know. But what are the problems with biodegradable waste? Okay, X, Y, Z. Now, my technique is perfectly suited for this X aspect of the biodegradable waste. So this is more convincing for the funding agency that, oh, you are actually targeting the majority section, which is the 50% of the section, and you will be able to curb majority of the problems. That is why having a little bit of information regarding the landscape of the things in which you are dealing is helpful. Coming to the next slide, again, it is just on the basis of percentage, like what percentage has compostable, recyclable, inert, and moisture things. You don't need to remember all those things. Again, these things are only for your understanding and making a picture in your mind that in which area you want to imply your techniques or your knowledge, or you think, okay, if this is the majority part, what are the problems in it? Oh, this is the minority part, and what are the problems in it? Coming to this, similar things are here. Same things are being repeated. It's just they are there in a redundant way so that you can understand multiple things and gain information and knowledge about where you want to impart your part. Because waste to energy conversion is not it is not just a subject which you learn, you take the certificate and you move on. This is actually a practical subject. The learnings which you are learning in this subject will definitely be implied in the like live projects, and they might help in creating certain policy through which we can make our world a better place for living, which currently it's a bit difficult because of our own activities. Then it was based on the agricultural waste. These are the certain broad areas in which a solid waste can be classified. Last but not the least,
Hello.
for yes.
Yeah, ma'am, I have a small question regarding previous slide. Previous to this one.
Okay.
Yeah. See, there are two columns. One is moisture and another is heating value. On the basis of these two parameters or these two properties, we are selecting the solid waste, which will be more suitable for energy conversion, right?
In a way, yes, yes.
Okay. So, what should be the heating value? Or the question is, for which particular heating value we should think that yes, this particular waste material is fit for the energy conversion.
See,
as
in
a cost
yeah,
efficient or the efficient
huh.
on all manner?
See, efficient in all manner is completely depend upon the uh, current technology you individual or you particularly have at your disposal. Correct?
So the sub question
Obviously,
is,
yeah.
what are the current technologies available?
You will read all, like you will study all those things in your upcoming week lectures, that how to convert a solid waste, liquid waste, and a gaseous waste at the maximum level through which you can get maximum amount of energy. Correct? Because again, as we discussed earlier, it is like a trade-off. You need to put energy to gain energy. Right now, we don't have any such procedure in which you are just initiating the process and it will keep going without inputting any energy in it. So, in the upcoming week lectures, you will particularly you will study about what kind of a material you should choose and the properties you have studied in this slide. What kind of a material you should use for generating what kind of energy. In general, 15 to 20 megajoule per kg of energy is a good starting point, according to me. Again, it's a very average thing. It completely depends upon the type of material you have. For example, here is paper, cardboard, and bags, right? The first column, as you can see, paper, cardboard, and bags. What kind of a paper it is? Is it a newspaper or a chart paper or some notebooks, right? They all have very different constituents in them. They have different thickness in them. So even for single paper, you need to imply multiple unit operations to get the maximum amount of energy. This column is the average of those things. Similarly, for the cardboard are of multiple types, like 3 types I know of. There can be more. Again, bags of what kind? Paper bags. Again, food bags are different because food bags might have some grease or oil in them. You cannot treat them as normal bags. You getting my point?
Yeah.
So deciding which component you want to use for generating maximum energy, it's a very, very, very variable process. It depends upon the constituent you have and the current thing which you can afford. For example, if we go for incineration, right? But for incineration, a lot of energy is required to reach that high temperature.
Exactly.
Again, the issue with incineration is you are generating higher temperature, which means you are inputting more amount of energy and you are generating gaseous waste also, apart from the ash and the char. So are you able to dispose those things also in a very sustainable manner? So if you have a proper pipeline in which you can dispose waste material in a sustainable manner, which again will require energy and money input. Correct? So these are the very, like what to say, unsaid rules which we need to consider. So whatever you are learning here, it is I guess it is a undergraduate course. So this course is here for you to just get an idea. Okay, this component is here. It has this moisture content. Okay, so if this is the moisture content, I need around 105 degrees, minimum 105 degrees Celsius to remove this moisture content, because with moisture you cannot generate energy. And then, oh, after for generating this 105 degrees Celsius, what amount of coal or electricity or hydraulics you need to impart, right? You getting my point?
Yeah, ma'am.
Yeah. So these are the
Means,
things.
ma'am,
So,
can we make a statement that it is
Hmm.
not at all feasible to make energy from grasses or the garbage which are high moisture content?
uh,
They have the
uh-huh.
very low heating value.
Huh.
On the other hand, they have a big amount of moisture.
It is in a way we can say, but for example, what if right now I cannot think of any procedure in which we might need high moisture content, but what if grass and garbage, if you are just burning them, or uh, they might produce more waste material, but these grasses and garbage, we can impart them to biological degradation, right? Though they are not giving us energy from an industrial point of view, but they are helping in the biodiversity, right? Because they are carrying out the biological chain in a way which you can use for generating compost, which will be useful for you from industrial point of view. So it is all interconnected. Is it clear?
Yeah, ma'am.
No. We'll move forward.
Yeah, sure. Thank you.
Yeah, welcome. So now we are talking about wastewater and their classification. These are the major types through which we can classify wastewater. And again, all these stats, all these numbers, you are not supposed to learn them. They are just there to give you some understanding about what is the scenario and with what kind of things you are dealing. Ravi ji, please don't use scribe on the screen. Then similar things, I'm not gonna talk much on them. As you can see, they are all numbers and just stats for you to get an idea about things. We'll move to the second introduction lecture. Hope you guys remember that. Are you guys able to see my slide?
Yes, ma'am.
Okay. Wait a minute, I think I have some. Is it visible?
Yes, ma'am.
Yeah. So this is the second introduction slide. Now you guys need to actively participate in it. So why we need energy from waste? Why we can generate energy from other things also, which we are using. So why we specifically need energy from waste product? I need active participation. You can text me in the chat box, and please don't play with the scribe, Umesh Yadav ji. So why we need energy from waste only? Why we need to go through such an extent of getting a separate dedicated subject for generating energy from a waste product? There are other things also, right, which we can uh, 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 take energy from. So anyone other from the people who are already taking part in the discussion? Anyone? It's pretty easy. Go ahead. Why are you shying about it?
Madam, actually, the treating waste also is like expense to us. So if we are processing, treating waste or disposal of waste also for a cost to us only, it costs us only. So we are generating waste from the so that we can minimize the energy, minimize the cost also, processing cost, and also safer disposal also. For
Can
like
I
a sustainable
put this
development.
Can I put this one point that currently what are the sources through which majorly we are using or generating energy? Please stop playing with the pen tool on your phone Zoom app. The scribes can be easily seen by everyone. Don't do it. Please don't do it. I will remove the participants if the same participant is doing it. Please don't do it and erase these scribes, whoever has done it. There is an eraser tool in your mobile's Zoom app. You can use it and you can erase these things. So my question was, what are the things through which we are generating energy?
Ma'am, right now we are majorly using coal, and other petroleum and crude oil products, and
Correct.
a little bit of nuclear power plants.
We will keep them aside because again, what is the major issue with nuclear energy? And it's
Waste
very
is the major problem. The
sorry.
nuclear waste is very hazardous to
Correct.
the normal waste.
And for coal, what is the major issue? Like why we are moving away from coal-based energy generation?
Ma'am, because the byproduct
Emits CO.
generated from the coals are causing the greenhouse effects, and as well as they are not environmentally friendly.
Any very one important point, which is similar for coal as well as other petroleum-based fossil
Going to
fuels.
extinct first thing, the coal is going to be extinct. And then
Yes.
other
Correct.
thing, the waste of coal, after firing the waste of the coal, like biochars, it's also causing the air pollution heavily, as well as water pollution.
So the main reason is because it is a limited source, right? We cannot keep digging for coal and it will keep appearing for us. Same with other fossil fuels. That is why we need to go and look for other or alternative sources through which we can generate energy, because coal and petroleum things are limited in nature and we are using it at a very higher speed in comparison to the amount of time and the conditions which are required for them to be replenished. Then on this slide, what was the main objective? Anyone? See, it is our first discussion class. Chances are I might like make other future classes based on today's discussion. So if people are not okay in discussing things, we can directly jump into questions and assign like previous year questions. I don't mind it. If you guys are okay with discussion, I am open. If you are not, we can move directly to the questions. You can write in the chat box. We can Kavita, are you able to listen me? Am I audible to you? You can just type. Okay, I'm audible to everyone, right? Who are present. Just give me a thumbs up in your. Just give me a thumbs up if I'm audible to everyone.
Yes, ma'am, audible.
Because I've received some messages. Okay. Okay. I'm audible to most of the people. Kavita, you can leave meeting and you can join again. Chances are there might be some issue with audio connection from your end. So do you want me to keep discussion or should we move to the questions? You guys can type in the chat box. Because discussion is a two-way thing and only few people are discussing, so I don't want others to miss out because they are spending their time in this and they are here for previous year questions. Okay, I need few responses. I received some. Okay. Okay, see, I'm getting majority for discussion, so I'll continue with discussion. You guys need to participate in the discussion also. So what was the main objective of this Venn diagram? It was
It gives some
sustainability.
function in the waste energy production.
Uh,
Hello.
so you are not audible clearly. Yeah, can you repeat once again?
Yeah, ma'am, in the environment and social and economic point of view, what are the functions about this concept?
It is, see, we can generate energy, we can, if we can say we are doing something, for example, you are studying, you are taking this course, you are taking this course not only because you want certificate or credit or whatever your motivation was behind taking this course. At the end of the day, the thing is you want to learn something and you want to give back to the society, you want to improve something, right? So right now what industries are doing, majority of the industries are doing, is that they are just making things without much concern about the environment or other things associated with it. They are basically making profit from the product which they are making at the cost of both environment, social or human interactions, or every aspect of those things. So one way to apply these learnings is to apply everything in a sustainable manner. What sustainability comprise of? It comprise of all these three things, which is social, which means you have to keep mind in the society to which you are delivering your product. Second, environment, because you are taking from the environment and you are giving back to the environment. You are taking good stuff from the environment, but if you are giving bad stuff to the environment, chances are in coming years, you won't have anything to extract from the environment. At the end of the day, it will be harmful to you only. And last but not the least, the economic section of it. As we have discussed, money plays a vital role, correct, in doing anything. Everyone wants to do best in their capabilities, but money or funds or grants, these are always the limiting factors. So if you are burning more money rather than generating it, chances are you are not doing good for you as well as for the society. So all these three things need to be kept in mind when you are generating or making some strategies for doing some process. Here, the process is with respect to getting energy from the waste. Second is, it is again what are the current management things available, which we are following, which we are using, so that we can make better judgment about how to use things and from where or what are the bottlenecks in which we can improve and impart our knowledge. Here, similar things, nothing much. Again, more of a strategy, more of numbers, and more of basic giving you guys certain idea about where you particularly stand on waste management things, right? Some more data, information, nothing much to discuss about it. Then similar things. I think we can switch back to our questions, because these are pretty simple things, pretty theoretical things, nothing much you need to concern about that you need to learn all these things. It is just there for you to understand how the current system in India and other are doing their work and is in action. Also, this information will help you out in figuring out the uh, deficiencies or bottlenecks in the system, where by your own understanding of things you can input and you can give back to the society. I don't think we will come back to these things when we are discussing some of the questions, because most of the questions are theoretical in nature and we can discuss there. Is it fine?
Yes, ma'am.
Uh-huh. Hmm. Can you all see my slides with my name on it?
Yes, ma'am.
Yeah. So as I have already introduced myself, I am Himanshi Singh. I am a PhD student here in IIT Kanpur at Biological Sciences Bioengineering Department. So I'll be in every week this Saturday 3 to 5, we'll be having discussion hours. These discussion hours are again in your hand. We can discuss, we can dig into questions, or we can just have a talk about things which you want to impart or you want to learn from this course, and I might be able to help you out. Everything else regarding lecture and certain concepts, you can, again, there's a same discussion or doubt clearing session tomorrow again, I guess Sunday, I don't know the timing, maybe it's 3 to 5 again. The mail will be circulated with you. So we have two active discussion hours for 2 hours each, where you can discuss, you can talk, we can discuss previous year questions, you can these discussion hours were basically meant for you to get an understanding of how to solve assignments. This was the whole sole purpose. But I wanted to include some of the discussion prior to questions because it will help you in getting bit more real with this course, because chances are some of the times it might see a bit superficial to you guys because you are not directly involved in the process, so it might seem bit superficial. So that is why I just wanted to incorporate some of the like mutual discussions in it, so that I can analyze where you guys are standing and where are some of your problem areas, so that in the next class we can target on those things. So in these questions, I want your active participation. Without that, I'm not going to tell you answers. You guys need to tell me answers in the chat box. No problem with that. And don't send me direct messages, so that everyone can see what are the majority of answers and people can get an idea what are some of the confusion areas here. Am I clear? Guys, am I clear?
Yeah, ma'am.
So this is our first question. ICP-MS stands for, people can text, people can send in the chat, or they can speak to me directly. Okay, I'm receiving some answers. Some more answers. Yes, yes. Good. As I can see, most of you who have said C is correct, which is inductively coupled plasma mass spectroscopy. It's a pretty straightforward question, so we are not going to discuss much on it. Which one is not biodegradable? Paper, cotton, glass, or tree trim? Answer in the chat box. Okay. More answers. Okay, good. Good. Some more. We have quite few participants. We can have at least more than 50% participation here. Yes. Good. So the correct answer is glass, right? Again, nothing much to discuss in this. It's a pretty straightforward question. Next question. Moisture and ash content of a municipal solid waste is determined by proximate analysis, chemical analysis, ultimate analysis, TOD, and DOD. More answers? Okay, good. And just don't send me answers which majority people are sending. If you know it, good. If you don't know it, even if the answer is wrong, go ahead, type in the chat box. Okay, good. So obviously the correct answer is proximate analysis. So should we know a bit more about proximate analysis? Or can you guys tell me what you understood Yes, Adarsh, I will share this whole PPT with you guys. It will be there, and all the lectures which I'll be discussing, it will be provided to you. So what we know about proximate analysis, can anyone tell me? I have most of the time I uses the similar things from the slide itself so that it can help you in getting more from the lectures. So what is proximate analysis?
To determine whether the coal is pure form or how much percentage of coal is present in that, to check that we are doing this. Am I right, ma'am?
See,
Hidden
here,
physical properties, the physical contents, ma'am. The hidden physical, like moisture, as it's physically hidden with that material.
What we will do with this information, like if we know the moisture content, if we know the volatile matter percentage or the ash content, what will we do with this information?
These factors affect the energy conversion mainly.
Correct. This will help us in designing more feasible further step measures through which we can get the maximum out of the solid waste which we have at our disposal. So someone said we want to know the carbon or coal, we want to know the coal percentage, if I'm correct. So coal here is not the right term. The term should be used as solid waste because coal is a very specific type of carbon molecule arrangement which is formed due to some very special conditions of pressure and temperature. Coal is one form of the carbon, but all solid waste is not necessarily majorly composed of carbon. Obviously, carbon will be there, but not majority of it will be converted to coal or will be coal. For making coal, you need immense amount of pressure and very high temperature. Am I clear? Okay. So the next question is bacterial infection in living system cannot be directly induced from air pollution, water pollution, soil pollution, or noise pollution. Answers in the chat box. Okay, I'm receiving some answers. Okay. Okay. I think it's a pretty straightforward question and we don't need to discuss much on it. Noise pollution is basically the noise which is not at all bearable to our, which is not in our normal audible range, and it creates some irritation and nausea and even headache in some of the people. All other types of pollution, that is air pollution, water pollution, soil pollution, are majorly they have bacterial component in them. Can anyone tell me, so it's out of the context of waste to energy conversion, but recently there was some issues, not issues, but there was some information regarding a particular type of microbe being present in air, which changed our whole disease management system because we were not aware that this microbe can be present in the air also. And because of this, we need to change certain policies. We need to change our whole way through which we were looking at looking the disease and how to control it. And this is one of the reasons we are having online classes. I've given you a huge hint. Most of the classes were online. Yes. So earlier it was thought that COVID virus is not at all present in air. And this I'm talking about in 2019 and 2020 early, when the COVID pandemic was starting. But when some scientists and researchers scanned the air of specifically hospitals where COVID patients were kept during quarantine, they got some positive results and it was made sure, okay, that COVID virus is present in air and can be transmitted through air also. One reason the masks were mandatory and hence the policies were changed to curb this. Coming to the next question. So it's a numerical type of question. Determine the stoichiometric air required to combust methane. I'm gonna give you guys exact 5 minutes and I want you to try this question on your own and give me the answer and then I will provide you the solution with it. But give it a genuine try. It's a pretty easy question. It's a pretty balancing question. It's a huge hint. Just give it a try. Your 5 minutes starts. Yes, Adarsh, I'm not speaking because your 5 minutes are still running. All of you just try to attempt this question, irrespective of whether you're getting the right answer or not. Just try to attempt it, and we will discuss in 2 minutes. some other responses also, if anyone has attempted. Otherwise, I'll give you the right answer with a solution. Who among you was not even able to attempt the question? Can I just get some hand raise or thumbs up or something like that reaction? That you were not even able to attempt it, irrespective whether it is wrong or right. So all of you were able to attempt it, right? Okay, that's good. Okay, so whoever has texted me 17.16 or any variation of 17.16 is the right answer. So we will see how the answer is there. I guess most of you already know it. It's a pretty straightforward balancing question. So methane, we want to talk about. Methane here, we will take it as 1 mole. So 1 mole of methane contains how many grams of carbon and how many grams of hydrogen? We can see here, it's 12 and 4. So the total mass of methane is 16 grams. Now we need a combustion reaction, right? So we need to oxidize methane to generate energy, which is CO2, H2O, right? Because these are the end products. If we combust anything to its maximum, these are the end products. So this can be done by 2 moles of oxygen. Again, it's a stoichiometrically balanced equation. And so 16 grams of methane requires 64 grams of oxygen. Hence, 1 gram of methane will take how much gram of oxygen? It will be 4 gram of oxygen. But here we are not talking about pure oxygen because we cannot impart pure oxygen. It is very costly. So here we are talking about air, and air is a mixture of oxygen, carbon, nitrogen, and all those things. So the percentage of oxygen in air is 21%, which means 1 gram of air has 0.21 grams of oxygen. So for 1 gram of methane, we need 4 gram of oxygen. Now, 4 gram of oxygen from air will be taken as to combust the same amount of methane. It's as shown here, and it will be with, oh, sorry, I think I have done some calculation mistake, but the correct answer is 17.16. I'll cross check it. Maybe there is some calculation mistake. I'll cross check it and we'll get back to you. Done? But all of you who have texted 17.16, it's the correct answer. I want to know here, as I guess Pradeep sir, you are particularly interested in methane, right? So though it is a numerical question, Pradeep sir, are you there?
Yeah, ma'am.
So as you're particularly interested in this methane, right? So though it's a pretty straightforward question, but what is the crux you get from this question? If you're getting anything out from this question?
Frankly speaking, I was not aware about this stoichiometry.
Acha, no problem. Have you tried to attempt it?
But now I got understood very well as per whatever you have explained. So I understood.
Okay. So see, that is, you are talking from the numerical perspective. What I want you guys to understand is that all the numericals, though not all of them pose the real life scenario, but we can get some idea about the real life problems from the hypothetical question. So here our question was basically, if you have some amount of methane, here we have taken 1 mole of methane. You have X amount of methane and you want to combust it, or you just want to, maybe for one reason you want to make some gas, or you just want to get water or CO2 out of it. So what amount of air you need to supply to get the desired amount of energy from it? So if you have 10 moles of methane, again, the calculation will be same, correct? From this, you will get an idea, okay, I have X amount of methane, and for 1 mole, 17.16 gram of air is required. So how much air I need to purchase so that it can be implied to the raw material or the amount of methane I have. Again, here it is the balancing act. If you have more air procured for your process in comparison to the amount of raw material you have, chances are you will be in loss. Why? Because you need to purchase air, you need to store it, all those require some amount of money input. So these type of questions will help you in generating your power plant, because you know how much methane you have, and for that amount of methane, how much air you actually need for them to combust. Here, the combustion was used. You can use similarly uh, different types of energy producing mechanisms, which will directly or indirectly be dependent upon this concept of stoichiometry. Everyone clear? Yogesh, am I not audible to you all? Everyone can hear me, right?
Yes, ma'am.
Yeah, ma'am.
Okay, okay, okay. And for those to whom I'm not audible, I will request you all to just uh, quickly leave the meet and reconnect. Don't worry, nothing will be lost. These videos, it's a recorded lecture, it will be provided to you along with the slide. Okay, so we'll move to the next.
Ma'am, one request is there. Don't call me sir. I'm your student.
It's okay. It's okay. It's in my habit. I'm calling everyone sir.
Yeah. No, I'm student.
Yes.
Thank you.
So, okay. So here comes the next question. So, which routes have relatively slower rate of energy production from waste, specifically with respect to biomass and municipal solid waste material? Biological routes, thermochemical routes, chemical routes, or none of these? Answers in the chat box. I will be needing explanations also from the answers, because this was covered in the lecture a little bit. Even if you are wrong, don't worry about it. We all are here to learn. More answers, at least 50% participation. These are all very straightforward questions.
Hello.
Yes, Ruchita.
Actually, ma'am, I'm unable to. There is some network problem. I'm not listening everything what you explained.
Okay.
You will say that this seat also after session.
You will be provided this video, and
Okay.
chances
Yeah.
are we have discussion are tomorrow also, Ruchita.
Okay, ma'am.
Okay, so
Thank you
you
so
can
much.
join that also.
Yeah, sure, ma'am. Thank you so
Okay,
much.
no
Yeah,
worries
yeah.
about it.
Okay.
Yeah. So obviously the correct answer is biological routes. So why we say biological route is the slower or slowest, we cannot say, but a slower rate of energy production route. Anyone can unmute and tell me.
Ma'am, because in biological routes, we go for the fermentation process, and it is completely based on the microorganisms and the rate from which the microorganism deal with the waste. And we can't alter or catalyze the process. So that's the main reason that they are the slowest. And in any other thermochemical routes or chemical routes, we can either increase the rate by adding a catalyst or changing the reactants, and in thermochemical routes we can also do it by the method of insertion and something others, but we can't do any alter process for the biological routes, so that's the reason they are the slowest.
Correct. And anyone else want to add something in this? Because that was a pretty round-up
Ma'am,
answer.
I have some difference of opinion.
Yes, Pradeep.
Because earlier guy told that we cannot add catalyst, but there are number of catalysts which we can add in this biological process. But the reason why the rate is slow, what I feel that because of the moisture percent, the biomass, and the microbial growth takes some time. That may be the reason the process is.
I would like to add here, the point which you are mentioning is not completely wrong, but like this is the same point I was gonna add in his point that he said biological roots are very slow because it depends upon micro, which is not wrong. But in the recent trend, I don't know how many of you are aware of metabolic engineering as a discipline, right? So in metabolic engineering, this is literally what we do. We re-engineer the microbes so that whatever the thing which we want to get out of that microbe is enhanced multiple times. Wait a minute. Yash and everyone, don't worry, these lectures will be provided to you. And even if some things are missing out today, we have discussion hour tomorrow also. You can join tomorrow's lecture and clear all your doubts. No worries. And these videos, both today's as well as tomorrow's lecture video, will be provided to you. So regarding metabolic engineering, right? So we can, to certain extent, enhance the speed of biological roots. But at the end of the day, on which it is dependent? It is dependent upon the inherent ability of the microbe, because biological roots are majorly dependent upon the microbes. So every living cell or organism has their maximum extent to which they can perform, because they have to first survive themselves and then they need to generate energy or other things which we are aiming them to do. So it is limited because it is dependent upon the inherent ability of the microbe and not the maximum extent to which we can push the boundaries of reactions such as in thermochemical and chemical. Maybe I'm clear a bit more now. You are not wrong, but I will still say keeping even that point in your mind, still in comparison to chemical roots and thermochemical roots, biological root will be the slowest in comparison to these things. And this is the same slide which you might have gone through in the lectures. It basically tells you the different types of roots which are available for specifically for solid waste management. We'll go to the next question. So it is again, it's a very straightforward question. So during heating values calculation of a waste material, HHV and GCV terms are used. So what exactly HHV and GCV stands for? Answers in the chat box. We have also solved some questions in the lecture. What was HHV and GCV? Is it high heating value and gross calorific value? Is it high heating value and gross carbon value? High heating value and green calorific value, or none of these? Okay, I am starting to get high heating value and low heating value. Rudra, the other is GCV. Can you give me? Correct. Others also? It's a straightforward question, nothing much to ponder on. Okay, one more answer and then I'll give you the right answer, because we have good number of participants. I need at least 50% of participation so that we can say this discussion And the questions discussion was a fruitful thing for at least half of you guys, and it will help you in solving your assignment. Okay, correct. So obviously it is a very straightforward thing, which is basically high heating value and gross calorific value. These are the quantities which we measure actually in real life, which give us an idea about the heat component or the energy component of the material. So I've taken the similar thing from the slide itself, and we can look here that HHV and GCV stands for higher heating value and gross calorific values. Okay, so our next question is, from the following flow diagram, identify the process. It's a bit different question. So our diagram is basically input is our waste material, which has been subjected to a reactor which performs endothermic reactions, and the residue and the end product is in the form of liquid, gas, and char. Okay, I started to receive some responses, more response. Just a request to everyone, please kindly mute yourself. Yeah, more answers. Okay, good. One more answer and then we'll discuss this question. Okay, so as I think all of you who have responded, all of you are correct. The answer is pyrolysis. So may I know what pyrolysis is? Anyone can enlighten me? Anyone of you who have
It's
responded?
thermal decomposition.
Thermal decomposition. Can we use more?
Burning in the absence of oxygen or limiting of oxygen.
Can you repeat, Prabhakar?
The burning of the waste or mass in the limiting of oxygen environment.
Okay. What is endothermic and exothermic reaction?
It's an exothermic reaction.
It's an exothermic reaction. What is exothermic reaction?
It's a evolving some heat energy.
But if you're
yes, ma'am.
If you're evolving or generating some heat, it won't be pyrolysis, because two processes, which are pyrolysis and gasification, these are the two processes which require energy instead of that they generate energy, like that of combustion or incineration. You get my point?
Yeah, yes, ma'am. Yes, ma'am.
So we can see here in the table at the bottom right corner that these some basic differences are given here between combustion, gasification, and pyrolysis. Coming to the options which we had, pyrolysis and gasification are the endothermic reactions. They require energy. They need input of more energy. And incineration is they break down things, which means they release energy, which means we need, if we are doing something with incineration, we might be needing some of the coolant unit operation so that we can gather and grasp this energy for our further use. So if both pyrolysis and gasification are endothermic in nature, why we said that the above flow diagram is a pyrolytic process. It can be gasification also, right? So the raw material of gasification is mostly heat and gas. It won't be liquid. It can be char and gas, but it won't be a liquid product. In pyrolysis, we will get liquid, gas, and char as products. Am I clear?
Yeah, ma'am.
Coming to the next question, very straightforward question. What chemical reaction makes biodiesel? Transesterification, sublimation, polymerization, or fermentation? Okay, I started to receive some answers. More answers. Okay. Okay, few more answers. These all are very theoretical questions. That is why I'm inviting more participation. We need to learn these things because if you don't know what is the core chemistry of things, then we won't be able to make unit operations on them. And I hope everyone is clear about unit operations because I'm using this term quite a while. Are you guys okay with unit operation? Do you
Yes,
have
ma'am.
any
Yes.
idea?
Yes, yes,
Okay,
yes, ma'am.
good. So, okay, I received some answers. We'll see what is the correct answer. Obviously, the correct answer is transesterification, and it can be directly seen in the slide. Nothing much to discuss here, I guess. Then the next question, again, very, very, very basic question. I need maximum participation in this. Waste can be classified on the basis of, we have revisited this while we were discussing. So, source and usability, compostability, combustibility, and biodegradability, or all of these above. Good, I have started. Nice. More
Biodegradable.
answers. Sorry?
Waste classified biodegradable.
Correct. And if you look at other options also, we will discuss this.
Yes.
The correct answer is obviously A. Why? Because as it can be easily seen in the slide, waste can be classified on the basis of source, biodegradability, combustibility, compostability, and usability. So, Ruchita, all of these are the basis of waste classification, not only biodegradability. On the basis of biodegradability, we have two types of waste, which are biodegradable and non-biodegradable. Correct? And if you have some issues, you can always go back to the lecture and revise yourself. Then, next question is the desirable the desirable characteristic of solid waste for higher energy production. We have discussed this in quite a brief. Is it the carbon content, the hydrogen content, the heating value, or all of them? Okay. Some more answers. I need answers from new participants also. Feel free to drop a text if you're not understanding anything. We will look into it. Okay. Okay. Nice. Obviously, it's a pretty straightforward question. As we have seen in the slides also, that the characteristic of a solid waste, or specifically if we talk about any waste, it is heating value will be the primarily. And if we talk about solid waste, hence its carbon content, its hydrogen content, and its heating value with respect to the current question will be the most appropriate characteristics to decide whether this particular solid waste is good for producing energy or not. Next question is gasification and pyrolysis process for energy production from biomass and waste are associated with. We have seen it previously, just before the last question. Is it a thermochemical conversion, a biological conversion, a chemical conversion, or a physical conversion? Again, for those who are not able to get the right answers, don't worry. These all things are present in the lecture videos. You just need to go back and listen properly. Don't be disheartened. These are very easy questions. It's a theoretical subject. And if you're not getting right now, don't be disheartened. You can always go back and learn. and you can go back to these discussion videos and learn. So obviously the correct answer is thermochemical conversion, and most of you are correct. And I will again send you back to this slide in which it is clearly mentioned. The next one is, which of the following density excludes the volumes of pores and interparticle spaces? Is it apparent density, envelope density, absolute density, or bulk density? Remember, there were three types of densities specifically with respect to solid waste, because based on the interparticle spaces, then only we'll be able to decide whether to compress the material or not to compress it. I am receiving some different answers. I will wait 1 minute for others to respond so that we can again discuss this question. More people take part. Yes. Few more responses. Try to picture this, that you have some solid material and you are only considering the exact volume. That's it. You are not considering anything. You are not even considering the pores which are present. You are not considering the interparticle spaces. So what is left in your hand when you don't consider pores and interparticle spaces? Okay, I think we can get the answer. And the answer is absolute densities. For those who have said, I guess there was a confusion between D, right? Bulk density. Bulk density, as the name suggests, that it will have everything in it. It's the bulk of things. So if you have a sponge with you, the sponge density will be a superficial density of everything it is comprised of. The absolute density is the density, absolute means the real, the most purest form. Nothing is more absolute than sun rising from the east and setting in the west, right? The absolute, which cannot be changed. Hence, if you look at these terms itself, you will get the idea of what kind of a density they want. Apparent density is basically the density which you're perceiving, right? You can see, okay, if this is a sponge, but if there are multiple sponges, there are distances because they cannot come closer to a certain distance among themselves. So it is the observed density. Absolute, as I mentioned, it is the real density. Density is basically what? Mass upon volume, right? So the real mass of the substance, excluding all the distances and the pores, is the absolute density. This is very simple, directly from the slides question. I want everyone to answer this question. So what apparatus is this? Is it a distillation column, a sieve analyzer, a ball mill, or none of the above? Everyone. If you are okay with, you can also write what is the use of this apparatus. Just few words. It was discussed quite extensively in the lectures, if I remember. Okay, I'm getting the answer. Can you try putting few words for which this apparatus is used? What is the purpose? Okay. Okay, nice. So I guess most of you know about this. With this we can okay. So with this we can, obviously it's literally nothing to explain here. So I have put the same slide. It was basically to get the particle size distribution of a solid material. There are few ways. First was sieve analyzer, the Tromble, and very high spectroscopic techniques which are used for determining the size distribution. It's bit out of the context here, but why we need to know the size distribution or particle size distribution of a material. Here it's a solid material. Don't think much about it. If you don't know, it's no need to worry. Anyone?
The uniform combustion, while we are burning solid waste, if the size are uniform, the combustion will be
One way, and also you can optimize the energy input, as we had discussed in our previous hour, that if things are heterogeneous in nature, chances are you need to impart more energy to it, so to get the desired product, instead when the distribution is homogeneous. So this is again a very straight question from the lectures itself. So find out the missing steps in the following depiction of ultimate analysis. So on the left, you have sample and the carrier gas. The first step is the combustion. The second step is what? Then it is gone through mixing process. Then fourth step is again a blank. And then last is by using some detectors, we detect the product. So what can be A and B? A can be separation or reduction, respectively, reduction or separation, drying or reduction, and last, separation and drying. And also tell me what is the ultimate analysis. Okay, I started to get some answers. It's a learner based question. So without spending much time on it, we can see obviously that the A is the reduction step, and B here the fourth step is the separation process. As discussed in the ultimate analysis discussion, basically, oh, you guys were supposed to tell me, yes, ultimate analysis is the one which gives detailed composition of waste. Specifically, what is the detailed composition? With respect to the constituent elements of C, H, N, and S. Yes, correct. And if any one of you have any questions or confusion regarding ultimate analysis, I will suggest you to go back to the lecture videos, and get yourself comfortable with the approximate analysis, ultimate analysis, and other type of analysis. These analyses help you to decide your next unit operation, because without knowing what you are dealing with, whatever you're going to do, it won't be feasible, sustainable, as well as not energy efficient. Coming to the next question, again, similar to the one, ultimate analysis of coal determines its dash content. Is it carbon, hydrogen, nitrogen, sulfur, carbon, ash, sulfur, nitrogen, carbon, sulfur, volatile matter, and ash, or last, carbon, volatile matter, ash, and moisture? Obviously, we have discussed in the previous slide itself. It is E, H, N, and S. I will again redirect you to the same slide. Okay, again, very straightforward question. In proximate analysis, moisture percentage, it's measured by drying the sample at dash for 24 hours. Is it 90 degrees Celsius, 80 degrees Celsius, 105 degrees Celsius, or 120 degrees Celsius? And I have a follow-up question in this question also. Okay. I don't think I need to spend much time in this. Obviously, the answer is 105 degrees Celsius. We can see in the slide here. So a follow-up question which I have, and I would like you to think about it. If the boiling point of water is 100 degrees Celsius, correct? Boiling means it will be converted to vapor, which is the moisture or the vaporous phase of water. Why we need 105 degrees Celsius? Why it is greater than the boiling point?
Madam, actually, the water up to 100 degrees Celsius, water won't boil. So if you're maintaining
Okay.
100 means, after that we need some heat for latent heat of vaporization.
Mhm.
So if that heat is not achieved by giving the that kiln or that setup, if not giving
Furnace.
the 100, not beyond that latent heat, it won't evaporate. That moisture won't go from the our sample. So that's the
Hmm.
only.
It is correct, but there is one underlying basic chemistry thing. Do you guys remember
Yes,
elevation in boiling point concept?
ma'am,
Huh.
boiling point of water is 100 degrees Celsius because when the vapor pressure of the liquid is equal to atmospheric pressure,
Hmm.
that is always is 100%.
Hmm. But we are doing this in a furnace, right? Furnace or a hot air oven,
Okay.
where the pressure will increase. So the boiling point will. Any idea? It's a very basic chemistry. I would like you
Lower.
guys to go
The
back.
boiling point will be lower when we
Huh.
increase the pressure.
Correct. But the other concept here will play role, and I would like you to, yes, I think Rudra mentioned it uh, nearby to it. I would like you guys to go back to the basic chemistry of 11th and 12th, where there is a concept of uh, elevation and boiling point and depression and freezing point due to the presence of some solutes in the water, because this moisture is not 100% water, right? There are some solutes dissolved in it. So if you dissolve something in pure water, its boiling point is gonna increase, and that increase depends upon the type of solute which is being dissolved. So just go back to that, understand it, and if you have any doubt, we can discuss it in the next class. Next question, pretty straightforward. I want answers from all of you. Wrinkler's method is used for the measurement of pH, conductivity, DO, or none of the above. It was discussed extensively in the lectures. Yes, the right answer is dissolved oxygen measurement. And I would like you to direct to this slide where it was extensively discussed. We indirectly measure the dissolved oxygen based on the content of iodide present in the reaction which we have set. Then next question, which analytical instrument is used for the measurement of trace metals in solution? There were two, I guess, which were discussed, one of which is given here and one of which we have already discussed as a first question. Just a hint. Yes, I guess I'm receiving some answers. I want more people to participate. Yes. Again, all these things currently, at least the first week assignment is majorly from the learnings which you have learned by attending the first week course. So the correct answer is atomic absorption spectrophotometer. And this was the slide. If you can see the 8th point where AAS, that is atomic absorption spectrophotometer, was used for measuring the trace elements present in the material. Why we need to know about the trace metals in our material? Anyone has like quick point to point out why we need this analysis?
For disposal of that waste after processing.
A quick answer can be this. Good. Next, it's a numerical based question. Again, I will give you guys this time 6 minutes because this is a bit of a large question. And this type of question was discussed in the lectures also. And chances are you might not remember the formula. So I'll give you the formula with all the variables described here. And your 5 minutes start here. Try to solve it and we will see this question in detail. Your 5 minutes starts now. Just try to attempt it at least once. No problem if the answer is right or wrong. Are we able to attempt this question? If not, don't worry. A similar type of question was solved by Professor Mandal in the lecture. You can always go back and revisit the concepts. I'll give you guys 1 more minute because I have only few answers. I'll give you 1 more minute and then we will see where we can move ahead. And I will request those who have sent their answers to just once revisit your calculations, because chances are that you are applying the same concept, but due to some calculation errors, you might not get the right answer. Should we discuss the question, or people still want to get some time just for attempting the question? Shall we go to the solutions? So those first, let's see what is the correct answer. The correct answer is C, that is 4749.09 calories per gram. Don't worry if you didn't get the right answer. Chances are, because it's a bit of a lengthy question, you might be facing some calculation mistakes, though your concept might be correct. As all the variables and everything mentioned here clearly, we will put these to our equations. Like, so what is given? We, from the excuse me, yeah. From this, we can see we have the formula of gross heat as T, which is the temperature difference multiplied by your equivalent water equivalent, minus E1, which is the correction for nitric acid, E2, which is the correction for sulfuric acid, and E3, which is the correction for the wire, which has been used for generating the heat by in which the bomb calorimeter was heated, and M finally is the mass of the compound or the material which we are heating, right? These are the variables. So we need to calculate E1, E2, and E3 from the things which are given in the question. So what are the things which are given in the question? First is the temperature difference. So the final temperature was 28, the initial was 26, hence the difference will be 2 degrees Celsius. The mass is 1 gram. T1 is given as 24.2 ml. So E1 will be, from the previous correction equation, we can see that E1 is equal to T1 times of that for Na2CO3. Hence, it will be 24.2 calories. Then C2 is the correction for sulfuric acid, and here it is given as 1%. And E2 is basically 13.7 times C2 multiplied by the mass of the compound. Putting these here, we will get 13.7 calories. Then again C3, which is the correction for the wire. So if 2.6 centimeter was uh, remaining, so how much was used? So it will be the difference of them, that will be 7.4 centimeter of the wire was used. And the E3, which is the correction for this PAR 450 wire, is 2.3 times of the C3, which is the wire fused for generating the heat. And this will give us 17 calories. Now we just need to put them in the formula, which is the temperature multiplied by the water equivalent minus E1, E2, E3. And then when you put all these values, you will get the approximate answer. And it is not necessary that you get the exact answer which is available here. If you are even nearby to it, 4749, it is completely okay. It is completely fine, because chances are some of you might be using approximation method and where you are rounding off things for quick calculations, so you don't need to worry about it. Is it the solution is clear to you guys? And if it is not, I will highly suggest you to go back to the Professor Mandal's video lecture. And even then, if you are not able to get it, we have discussion class tomorrow also for the similar things. You can come back there also and we can discuss again. Is it fine? Are we good?
Okay,
Can I
ma'am.
get
Yes, yes.
in the chat? Yes. So this is all from me